Hello students, welcome to your channel again. Hope you are doing well in this pandemic situation. This is the sixth part of the ongoing chapter Light. If you have not watched the previous videos, you can click on the I button or you can go to the description, you will get the link. So without wasting more time, let's start. So students, today we are going to discuss about spherical lenses. So first we have to know that what is a lens. A lens is a transparent glass and the surface of the lens are spherical, just like concave mirror and convex mirror. The surfaces are spherical. Now what is transparent? Transparent means a object through which we can see, that is called transparent. So lenses are transparent. That means through lenses we can see an object. Lenses are basically two types, convex and concave. Just like convex mirror and concave mirror, lenses are also two types. For convex lens, the middle portion is thicker, whereas the side and edge portion is thinner. But for the concave lens, the middle portion is thinner and the side portion is thicker. So these are the differences between convex and concave lens. Now if a parallel beam is falling on a convex lens, the rays of the light meet at a point. This point is called focus. Now focus is present both the sides of a convex mirror. Now as the light meet with each other, parallel lights, the convex lens is called converging lens. Whereas for concave mirror, when a parallel beam is falling on the surface of a concave lens, in that case the rays are spreading outside. That is why it is called diverging lens. Now for the concave lens, the focus is virtual. That means if we draw the lines behind the spreading rays, we will find it appears to be starting from one point. That is the focus, and that is why the focus is virtual. So the distance between the focus and the lens is called focal length. Now we know what is convex lens and what is concave lens, right? Let's see the images formed by the lenses. Now what is image? When we look through the lens, the picture of the object is the image. So first we will learn about image formed by convex lens. As we know, convex lens is thicker at the middle and thinner at the edges, and convex lens is a converging lens. So convex lens is actually, the properties of convex lens is almost same as concave mirror. Just like concave mirror, convex lens is also, the image formed by the convex lens is also depends on the distance of the object from the convex lens. So first we will see if the object is placed at a far distance from the lens. So here you can see this is a convex lens and this is a candle which is far from the convex lens. To obtain the image, I have put a screen as a paper behind the convex lens. Now as we can see that the flame is appear on the screen, and if you look carefully you will find that the flame is diminished. That means the size of the flame is smaller, and also the flame is inverted. and the flame is real because actually light passing from the paper. That is why the image which is formed by the convex lens when the object is far from the lens, the image will be real and inverted and diminished. Hope you understand. Now it is same for the sun. As we know, sun is far from the our earth. Now if we place the convex lens in front of a sun rays, the sun rays are parallel rays, so it will meet at a point. So if we bring a paper and try to achieve that point, you will get the point, a bright point. And as the sunlight contains not only light, it contains also heat. That is why all lights and heat will meet at a point, so that for that point the temperature is very high. Now if you put this type of screen, or if you put a piece of paper in front of the sun rays, if we place a convex lens and if you achieve the bright spot, you will find that from the bright spot smoke comes out because the paper start burning. If you hold the paper for 2 to 3 minutes, you will find that the paper start burning. That is why we should not look directly to the sun with the help of convex lens, because it is very dangerous. Now let's see what will happen if we place the candle just far from the double focal length. Here you can see this is a now we bring this candle just near to the double focal length, and here also you will find that the image size is just increased from the previous, but it is still inverted and diminished from the actual flame. And also this image is also real because actually lights passing from the screen. Now we bring this candle between the focal length and the double focal length. Now what we can see that this image is inverted, but the size increased and it is magnified. Now if you compare the flame, actual flame, and the flame which is appeared on the screen, you will find that the flame on the screen is much bigger than the actual flame. That means it is magnified now, but the image is inverted and as well as it is real image. Let's see, if we put the object just near to the convex lens, then what will happen? Now if we bring this candle near to the convex lens, we will find that no image will form on the screen, and image will form on the convex lens, and the image is virtual because no light are passing from the screen. So that here you can see that the image is magnified, and not only magnified, the image is erect now. That means same side up and same side down. So we have seen that if we bring the object just near to the convex lens, the image formed by the convex lens is virtual, erect and magnified. So as you can see that convex lens, the image formed by the convex lens depends on the distance of the object from the convex lens. It is same as the concave mirror. For concave mirror also we have seen that the distance, the image formed by the concave mirror is depends on the distance between the object and concave mirror. So students, here you can see I have used a glass of water as a convex lens here.
because if we see from the top, so we will find that the surface this side and this side is almost look like a sphere. So this is a spherical surface, so this can be used as a convex lens. Now I have used this symbol as an object. So this symbol is a left arrow, you can see now. Now if we see this arrow through this lens, you will find that the direction inverted, right? Because the distance between the object and the lens is far. That is why it is inverted, and as well as it is real image. Now if you just bring this direction close to the lens, so you will find that the image size increases, but still it is erected, that the image is inverted, right? And as well as it is diminished, means the actual object is bigger. So now if we bring more closer to the lenses, then it will, now if we bring this object here, so you will find now this object is uh, same side up and same side down, just like a lens, magnifying lens. So this is a erect image. It will produce a erect image now, as you can see, because this side is same side up and same side down here. So this is a erect image. So this is the practical example of convex lens. Now if you bring back again, so it will again inverted.
Let's see what is magglass. Magnify means to make something look bigger. Actually, convex lens is used as a magnifying glass because of the properties of convex lens. A magnifying glass is a convex lens which is used to make something look bigger. If a object is placed just close to the convex lens, means short distance from the focal length, in that case the object appears to be bigger than actual. So it helps us to read the books in which the letters are very small. If we use the magnifying glass to read the book, it will be the letters are appear to be bigger. That is the use of convex lens. So convex lens has two uses actually. Convex lens is used as a magnifying glass, and also there are some uses of convex lens, that is it is used to make spectacles, it is used to make cameras, it is used in microscopes, telescopes and binoculars. These are the uses of convex lens. Let's see what are the image formed by the concave lens. Now concave lens is such a lens in which the middle portion is thinner. That means it is bent in from the both sides, and the focal length is virtual for the concave lens, right? Now as you have seen that for the convex lens, the image is depends on the distance between object and convex lens, but for the concave lens it is does not depends on the distance. Whether an object is placed at a large distance or a close distance from the concave lens always form the image which is virtual, erect and smaller than the object. So you will remember that it is almost same as the convex mirror. Now if we place a concave lens here, and if we place a candle here, and if we place a screen over here to see the image, we will find we will not
get the image on the screen because the image is virtual. So the image will form on the concave lens. As you can see that the image is erect as well as virtual and diminished. Now if we bring closer, little bit closer from the concave lens, we will find that the image size increases but still it is diminished from the actual object and as well as erect. Now if we bring continuously, if we moving this candle continuously towards the lens, we will find that the image is keep increasing but still the image is, the size of the image is smaller than the actual object and also it is erect. So this is the difference between the image formed by the convex lens and concave lens. So concave lens always make an image which is virtual, erect and smaller than the object. Now let's see what are the uses of concave lens. Concave lens are actually used as making spectacles. Concave lens is also used as some kinds of special telescopes, and concave lens is also used as peepholes on the door. In the door on the hotel rooms or flat, you will find a small hole. In that hole, concave lens is used. So these are the spherical lenses. Hope you enjoy the video, and if you have any doubts or any queries, you can ask me in the comment section. And if you think that the video is helpful for you, please like and subscribe my channel. Thank you for watching this video.